Alright, so our goal for this lesson is to be able to convert between exponential and log form, to be able to evaluate logs, and to use the change of base formula. So as we're working through this lesson, make sure you're thinking about when do we use the change of base formula. So first of all, let's start out with what is a log? What is a logarithm? So a logarithm, or we shorten it to log, is another way of writing an exponent. So logarithmic form is this right here, and we read it as log base b because it's in that subscript, it's below, of a equals x. So that's just a form that you're going to need to know, log base b of a equals x. So like if I look down here for example 1, this would read log base 3 of 9 equals 2. And so I can rewrite that logarithmic form into exponential form. So the exponential form is b to the x equals a, which we've seen before. And so let's go ahead and look at where the pieces come from when we go from logarithmic form to exponential form. So let's just think about the words that we use, log base b. And when I look over here, b is the base. So that makes sense. Log base b of a equals x. So the x is the exponent in the exponential form, and the a is what that expression is equal to. So these are two things that you're going to need to memorize. You're going to need to memorize that log base b of a equals x is the same as b to the x equals a. So go ahead and make sure you have that written down and that makes sense in your head as far as which pieces go with which in the different forms. Alright, so we're going to start with just basic converting. So that's the first part of our objective, is to be able to convert from exponential to log form and then from log form to exponential form. So we're going to start with log form to exponential form. So here is log base 3 of 9 equals 2. So when I look up here, log base 3, so that becomes my base, of 9, that becomes what it's equal to, and then the 2 is the exponent. So let's go ahead and write that out. And when I think about it, 3 to the second is 9. So I did that correctly. So go ahead and pause the video, and I'd like you to try number 2 and number 3 on your own. So hopefully with those you were able to come up with that 6 to the third equals 216, which if I multiply 6 times 6 is 36, times another 6 would be 216, so that makes sense. And then 7 to the 0 equals 1, and remember from Algebra 1 that anything to the 0 power is 1. Alright, so let's look at number 4. It's a little bit different because I have log base negative 2 of 16 equals 4. So go ahead and pause the video, and I still want you to write it out, and then we'll talk about why it's a little bit different. Alright, so hopefully you were able to write negative 2 to the 4th equals 16. However, I'm going to guess some of you did not think to put it in parentheses because it's the value negative 2 being raised to the 4th power. It is not just negative and then 2 to the 4th. So let's look at why this is true. Alright, so that means negative 2 times negative 2 times negative 2 times negative 2, which if I multiply 4 negatives together, I'm going to be positive, and 2 times 2 times 2 times 2 is 16. Now, if I had left it without the parentheses, the answer would end up being negative 16, which is not 16, because I would take the negative of 2 to the 4th, and 2 to the 4th itself is positive 16. So those parentheses are really important. Alright, go ahead and try number 5 and number 6. Pause the video. Alright, so in number 5, you should have gotten 4 to the negative 2 equals 1/16. And if we remember, that negative exponent moves it to the denominator, and the negative goes away. So in the denominator, I'm going to have 4 to the second, which is 16. And then the numerator, I'm just going to have 1. And then for number 6, I have 9 to the 3/2 equals 27. And we're going to talk more later about what an exponent that's a fraction, what that means. But this is about the process of being able to just rewrite from that log form. So go ahead and pause the video and identify any areas that you're confused on that you want to talk about tomorrow. Alright, so for this one, we're going to work backwards. We're going to go from exponential form into that log form. So go ahead and remind yourself of what the different pieces, where they come from, and we're going to walk through this first example together. All right, so just a reminder, log base b of a equals x is the same as b to the x equals a. So let's go ahead and take number 7, which is 14 to the second equals 196. So I know that the base is the same. So when I look at this, the base is 14. So I know I'm going to have log base 14. And when I look at this, what it equals to becomes what the log base 14 of what it's equal to. In this case, it's going to be 196. And then my exponent becomes what my log is going to be equal to. And so I've got log base 14 of 196 equals 2. And I can always check it by 14 to the second equals 196. So that is correct. All right, go ahead and pause the video. And I'd like you to try to write out from exponential form to log form the remaining 5 problems. All right, so hopefully you were able to get these numbers. So go ahead and check through the remaining problems and mark any that you have questions about, and we can talk about those when we get together. So go ahead and pause the video. All right, before we get started in the second part of our objective, evaluating logarithms, I do want you to be aware of this idea of a common log. So a logarithm with base 10 is called a common log, and it can be written without a base. So log base 10 of x can also be written as just log of x. I don't need that base 10 in there because this is the common log. All right, so when I'm thinking about evaluating logarithms, all right, there's 2 questions that I'm going to use when I'm evaluating these logarithms. So the first question is, how can I rewrite the log into exponential form? So if you notice, all of these are in log form. So we're going to use the knowledge of what we've already learned to rewrite them into exponential form. So when I look at number 13, example 13, I see I have log base 7 of 49. It doesn't have equals anything, but I don't know what it equals. And when we don't have when we have an unknown in algebra, we like to say equals x. That's the same. I could rewrite it like that. So how can I rewrite the log into exponential form? So that would give me 7 to the x equals 49. And so then the second question is, what value for x would make the equation true? So what power would I have to raise 7 to get 49? And so when I think about that, x would have to be 2 because 7 times 7 is 49. So that would be raised to the second power. All right, so number 14, how can I rewrite the log into exponential form? So go ahead and pause the video, see if you can rewrite that into the exponential form, and if you can take it that step further and think through what value for x would make the equation true, go ahead and try that now. So hopefully you were able to rewrite it as 3 to the x equals 27, and then what value for x would make that true? Well, what can I multiply? How many times can I multiply 3 to get 27? 3 times 3 is 9, so that would be to the power of 2, times 3 is 27. So x has to be 3. All right, go ahead and pause the video, and I'd like you to try numbers 15 through 19. For the sake of this lesson today, we're not going to do number 20, but I'd like you to attempt the remaining 5. All right, so hopefully you were able to come up with the same exponential forms for each of these expressions and then solve for the exponent that would make each of them true. So go ahead and pause the video, look through these answers, and make sure that you have the same answers. If you have any questions or don't understand where I got something, mark it and we will talk about it in the lesson. Sometimes it's not always easy to see exactly what exponent value would make this log true. So we have what's called the change of base formula. And the change of base formula says that log base b of a is the same as the log of a divided by the log of b. So when I have a problem like example 21, the log base 16 of 64, and I'm going to evaluate it. Well, 16 to the what power is 64? That's 16 times 16 is never going to be 64. So I need a different method than just evaluating it using my knowledge of exponents So I can use the change of base formula. And over here it says choose the base 10 because there is a calculator button for it. You will need your calculators for these using the change of base formula because we're going to get some decimals. And anytime that you do get a decimal, I want you to round it to 4 decimal places. That's just going to be our standard. If it doesn't tell you explicitly, always go to 4 decimal places. All right, so let's look at 21. Log base 16 of 64. I'm going to rewrite it using the change of base formula. And when I do that, I get log of 64 over the log of 16. And if you notice, we didn't use any base here, so we're going back to that idea that if there isn't a base written in, we're using base 10. And we want to do that specifically because that's what our calculator can do. We have a button on there. So go ahead and in your calculator, I'd like you to type this in. Be very careful that it might be helpful to put parentheses around log 64 divided by parentheses log of 16. Otherwise, your calculator might try to do something else using the order of operations. So I'm going to use the button that's next to the 7 on my TI-83 that says LOG, and when I do, I end up with it equals 1.5. And I can always check my answer by taking 16 to the 1.5 power, and when I type that in, I get 64. So what I'd like you to do is using the change of base formula, I'd like you to try these 5 remaining problems and remember to round to 4 decimal places. Go ahead and pause the video now. Alright, so look over these answers, compare them to yours, the setup and both the answer, and if you didn't get that and you can't figure out why, make sure you mark it and we will talk about it when we discuss this lesson. Alright, before we wrap up this lesson, I want you to think through our 4 objectives today. So the first objective was to convert from log form to exponential form, then to convert from exponential form to log form, then evaluating logs just basic using our knowledge of exponents, and then evaluating logs using the change of base formula. So I want you to look at your work for each of those, and I want you to come up with a common mistake that you think students make when they do each of these problems. Go ahead and pause the video so you can do these reflections. And the last thing I want you to do is, as of right now, with your understanding so far, I want you to come up with your summary of the different parts of this topic. And then how would you rate your understanding of this topic? So from a scale of 0 to 3, how do you feel about this topic so far?